So I'm going to start with the first unit. So the first unit, unit 1. Don't forget, the topic we are looking at is Newton's law of motion. So I stated 3 laws in the last class, and I explained to you the indication and the inclination behind those laws. And I said that once I have already explained everything I feel Jam is going to ask you guys relating to those laws. But again, when we see some questions, I'm also going to dive deeper into some more explanations of what is still essential for you guys to understand. Now, I have some questions there with me, I think like 6 of them, which is relating to one very important thing. Now, I showed you guys that force is equals to MA, right? This is very important for you to note. Very, very important. You have to know that F is equals to MA. So if you don't know that in the last class, you should know that now. Now, since we know A to be equals to V minus U over T from V is equals to U plus AT, we also know A to be V squared minus U squared over 2S from V squared is equals to U squared plus 2AS. If you make A stand alone, this is what you have. If you make A stand alone here, this is what you have. So we can change these formulas and say that our F is equals to M into brackets V minus U over T, or M V squared minus U squared over 2S. It's also possible. Do you understand? Do you understand? So I want you guys to understand that. Very, very important. Also, we can also write acceleration as V over T. Velocity over time. Yes, acceleration on Jebe. That means that our F would also be mv over T. So you see this one here. You want to use this formula in the couple of questions we are going to solve going forward now. So the first question I have says that, question number 1. A rocket burns 0.001 kg of fuel each second. And ejects it as a gas with a velocity of 5,000 meters per second. What force does the gas exert on the rocket? A, 500,000 Newton. B, 500 Newton. C, 15 Newton. D, 5,000 Newton. This is 1982, question 34. Now, the question here is quite simple. Like I used to tell you guys, anytime you have a calculation question, don't bother yourself. Just write out the parameters. From the parameters, you would know the formula to use. The rocket burns, the mass is 0.01 kg. Each second, the time is 1 second. Each second. And ejects as a gas with a velocity of 5,000 meters per second. What force You have to find F. So you can see, we have the formula FMVT. FMVT, this formula. So we can get our force as what? MV over T, which is M is 0.01 times V, which is 5,000, over T, which is 1. So if you multiply this, 1, 2, it will cancel 2 of the zeros. That will be 50 Newton. And that's option C. Is this clear? Question 2. A force of 16 Newton applied to a 4 kilogram block that is at rest on a smooth horizontal surface. What is the velocity of the block at t equals 5 seconds? A is 4 meters per second, B is 10 meters per second, C is 20 meters per second, D is 50 meters per second. 1983, question 38, I think. It's very simple again. Write out the parameters. A force of our F is what? 16 Newton. Applied to a force of 16 Newton applied to a mass of, so the mass is 4 kg. That is at rest. At rest, that means U is 0. On a smooth horizontal surface, what is the velocity? You have to find V of the block at t equals what? 5. So at t is 5. Again, what formula do we use? F is equal to mv over t. So you can find V from there. So F equals mv over t. So let's, over 1 year, let's cross multiply. Ft is equals to mv divided by m divided by m. And our V is Ft over n. Our F is 16. Our T is 5. And our M is 4. Yeah.
4.
So our V, 4 year 1, 4 is 16, 4. So 4 times 5, that's 20 what? Meters per second, option C. So anytime you have questions like this, you just have to look at the parameters you have and know exactly what to do. So question 3, a jet develops a thrust of 270 Newton seconds when the velocity of the exhaust gases relative to the engine is 300 meters per second. What is the mass of the ejected material? A, 81 kilogram, B, 9 kilogram, C, 0.90 kilogram, D, 0.09 kilogram. So this question is, I didn't write this here. Okay. A jet develops a thrust of So the thrust is 270 Newton seconds. That is telling you Ft. And remember that Ft is equal to what? mv. This is another formula that you have to take note. Still from F is equal to, you can see from here, I just pick this numerators here. So this Ft, Newton seconds, is your what? 270. So Ft here is 270. So your Ft is what? 270. The velocity is what? 300 meters per second. You have to find the mass. So divided by m. So V is equals to 270 over 300. 0, 0, 3 here, 9, 3 here, 10. So that's 0.9 kilogram. Option C. Is that correct?
Not clear, so
So the question says, a jet develops a thrust of 270 Newton seconds. You see the formula F is equals to mv over t. If you multiply t and f together, ft, this ft is the 270. It's your impulse. Impulse is force times time. So they're giving you your impulse like that at 270 Newton seconds. How do I know? I have Newton, I have seconds. In this formula, in this value alone, it means that there's force inside it and there's time inside it. So my ft is what? 270. And my v is what? My v is 300 meters per second. So I need to find m. So ft is equals to mv divided by f by v divided by v. So my m is ft, which is 270, over v, which is 300. If you press the calculator, you're going to get is 0.9. Just do 270 by 300.
okay,
Can see the calculator I'm using. This is the calculator you guys should practice with. 0.9 kilogram. Is that clear?
yes, sir.
Excellent. Amida, you have a question, please go ahead, ask.
Yes, sir. Sir, you wrote Ft over m equals to mv over m. So m cancel m. So v is the velocity, and we are given the velocity here as 300. So you said you wrote
Sorry,
v equals
I made a mistake. I made a mistake. It's actually supposed to be cancel v, not m. So that's why I did it again.
Okay, sir.
Sorry, I made a mistake. Thank you so much. Is it clear to you?
Yes, sir.
Okay, good. So question 4, it says, when, this is 1988, question 7. When taking a penalty kick, a footballer applies a force of, so I'll just write the parameters. When taking a penalty kick, a footballer applies a force of 30 Newton for a period, that's the time, a period of 0.05 seconds. Period means time. If the mass of the ball is, so the mass of the ball is 0.075 kilogram, calculate the speed with which the ball moves off. So that's the velocity. Option A, 4.5. Option B, 11.25. Option C, 20. Option D, 45. So if we come to this question here, we have other parameters. We just have to find V. Good. Somebody has already done it. F is equals to um, mv over t. So we have to find V. So we cross multiply and we say ft is equals to mv. So we divide it by m, we divide it by m. So our V is going to be equals to F, which is 30, times T 0.05 over, sorry, F, which is 30, times T, which is 0.05 over 0.075. So we can do calculator, 30 times 0.05, 30 times 0.05. This is the exact same calculator you are going to use, something like this. That you are going to have to minimize and be checking your screen. So you guys have to acclimatize to it. That's 20 meters per second, option C. Good. So I'll just give you guys. Okay, another question I have here. Okay, you guys will solve this question 5. A rocket burns fuel at the rate of 10 kilogram per second. I love that question so much. A rocket burns fuel at the rate of 10 kilogram per second and ejects it with a velocity of 5 times 10 raised to power 3 meters per second. The thrusts exerted by the gas in the rocket is A 2.5 times 10 raised to power 3 Newton, B 5 times 10 raised to power 4 Newton, C 5.0 times 10 raised to power 2 Newton, D 2.0 times 10 raised to power minus 3 Newton. Okay, let's try this quickly. 1 minute. People are already dropping the answers. I hope you're among those that are dropping the answers. So, a rocket burns fuel at the rate of 10 kilograms per second and ejects it with the velocity of this thrust. So when we say thrust, we mean force. Thrust means force. Now, this 10 kilogram per second, if you look at F is equals to mvt, the mass and the time has been given. You've been given this one, and you have the velocity, this one. So just do F is equals to 10 times 5 times 10 raised to the power 3. So this 10 is going to add to this 10 here. So from 3 to become 4. So F is equals to 5 times 10 raised to the power 4 Newton. And the answer is just option B. Very simple. You don't even need to do anything. Any question? So I'm going to write question 6 on the board. You guys should go over it in like a minute, please. So two bodies have masses in the ratio 3 to 1. They experience forces which impact them to accelerate in the ratio 2 to 9, respectively. Find the ratio of forces the masses experience. Questions like this, if you have not seen them, you might struggle on how to solve them. So you need to have seen these questions to know exactly how to do it. Do you understand? You need to have seen this question to know exactly how to do it. Somebody already gave me the answer, which is correct. Good. So two bodies have masses in the ratio 3 to 1. So body A now and body B, their ratio of their mass now is what? 3 to 1. They experience forces which impact them to accelerate. So the acceleration is in the rate 2 to 9. So what will be the ratio of their forces? What is force? Mass times acceleration. So just multiply. 3 times 2 is 6. Ratio 1 times 9, 9. So 6 to 9, if you take it to the lowest term, 3 here 2, 3 here 3. So the answer is 2 ratio 3, which is on C. Rohima and Ben Becker, was this the method you guys used or use something different?
Something different, sir.
Okay. Was it longer or shorter?
Longer.
Good. Okay, I used to tell you guys, any question you have, if you are spending more than 1 minute, know that the method you are using is wrong. So that's the reason. All right. Now, guys, with this, We are going to move to a very interesting aspect that I forgot to explain in the last class. I actually did not forget, but there was no time. So it is weight of object in a lift. Weight of object in lift. Now, when an object is in a lift, we can have three cases. Case 1, case 2, and case 3. It can be one of these three cases. Case 1 is the lift accelerates upward. Case 2, the lift accelerates downward. And case 3, the cable is distorted. Cable it is still coming down. Do you understand? For case 1, it is going up. For case 2, it is coming down. But this lift, it's not just moving by itself. It is connected to some bodies, extended somehow. So in a case whereby it's accelerating upwards, the tension is the force on the rope. So that tension, which is the rope on the string of the lift, is greater than the weight of the object inside the lift. So this tension is greater than what? The weight of the object. When the object is accelerating upward, the tension, which is the rope of the lift, is going to be greater than the weight of the object, because that tension has the object inside the lift. So that tension, that wire that is dragging that lift, is greater than the weight of the object. Do you understand? So there's an indication to this. And that indication is that the object appears heavier. The object is going to appear as if it is very, very heavy. And we can write this mathematically, that the tension is going to be equals to, or let's say that the tension will be equals to the weight of the object plus the force. So we can say that T, because when we say weight is equals to mg, and force is equals to what? Ma. Weight is mass times gravity. Gravity that the object is coming down. So the tension now, mathematically, will be equals to what? M into, so let's just say mg plus ma. So the tension would be m into brackets what? G plus a. So this is what is important for you to note. And the fact that the object is going to appear what? Heavier. This one is important. This one is also important. Case 2. The lift accelerates downward. In this case, the weight is going to be greater than the tension. Because all the force is coming down. So the tension on the lift is also coming towards what? Towards the weight. So the weight is always acting downwards. If you have an object in a lift now, the weight is accelerating, it is coming down, acting downwards. But the cable is suspended somewhere like this. So if it's going up, the force tension is going up. If it's coming down, the tension is also coming down. So in this case now, both the tension and the weight are acting towards the same direction. So the weight is going to be heavy. Which name are heavy to be heavy? So the weight is going to be more. Now the inclination to this is that the object is going to feel lighter. The object feels lighter. If you have never been in a lift before or an excavator, when you are going up, it appears as if you are heavy. But when you are coming down, it appears as if you are light. So the object feels what? Lighter. The indication to this is that our tension will be equals to weight minus force. So tension is going to be equals to mg minus ma. So tension is going to be equals to m into brackets what? G minus a. What is important here to take home is this. So you can see the difference. From the question, if you hear that the object is accelerating upward, you know you are going to use a plus value. If you hear that the object is accelerating downwards, you're going to use a minus what? Value. That's the difference. The object feels lighter. Last but not least, the cable is distorted. That cable that is holding the object, what the cable is distorted. Somebody cuts the cable, or someone cuts the cable, or the cable becomes loose. So it means that what? Our weight is equal to our force. And the indication is that what? The scale reads 0. If you have to measure the tension, it's going to read 0. And the object experience what? Weightlessness. The object appears weightless. So come and jive, you just fall. It will fall with gravity. So, or we can also say that our acceleration A will be equal to what? G, gravity. You can also say this. Both are correct. Now, what this means is that that place that we have our T to be equals to mg minus A. Remember that it is coming down. That's why we are using this formula. But A is already G. So we have our T to be equals to what? M into bracket G minus G. So T is equals to M, G minus G is 0. So our tension is going to be equals to what? 0. That's why we said the scale is going to read what? 0. Because when it's experienced weightless, or when it's being distorted, or it snaps, or it cuts, the object just what? The lift just what? Falls freely. And it experiences what we call what? Weightlessness. Is that correct? Any question on this so far? There are so many theory questions here.
Please, can you explain that the case 3?
Case theory, okay. Apart from that, any other question? Any other question apart from that? Okay, in the answer of question, we'll just look at the case 3 again. Short questions. Sir, what if the weight is suspended? In all the cases I explained, the weight is suspended. It is only in case 3 that it is not suspended. What do you mean by suspended, if I can understand you? Do you mean that inside the lift, there's an object inside the lift, or what do you mean? I don't understand what you mean by suspended. Can you explain better, Benny Beko? You can unmute and talk, Benny Beko. I can understand you better.
I meant if it is hanging at a particular distance, like it is
Above
not
the
going,
ground.
it's not coming down, just hanging at a particular distance.
Okay, I think I understand you now. I'll explain that. Let me explain this. The cable is distorted. It means that that object is in a lift. You know, an object that is suspended in a lift is under a particular influence. What is taking it up and down is a particular wire or cable. Suddenly, that cable snaps. It has happened before in one Lagos clinic, hospital, that led to the death of one very young doctor. That doctor was still a resident doctor. The doctor just finished maybe 7 level or thereabouts, and he was doing his residency. And it led to the death of that doctor. I think she was a female. I think it was a female doctor. Yes. Happened, I think, 2 years ago or thereabouts. I heard about the case, and it was so devastating. That's to tell you the state of the healthcare of Nigerian. So they said that the lift became very faulty, and people don't even know. The lady was just there. She entered into the lift, and the next thing, it snapped. It killed the lady. If I'm not mistaken, I think she's the only daughter of her parents, if I'm not mistaken. Again, what has been destined is going to please you about. That's by the way. But the bottom line is that this lift used to snap. Yes, Oman snap, Oman gay. So, what will happen to the object inside the lift? That at that particular time, that acceleration A is going to change to G, because now the lift is not going up and down by the influence of this rope again. It is going up and down by the influence of gravity. Is that clear? Our A is equal to our G. So because it's coming down, we are going to use the formula for C is equals to M into bracket G minus E. Now this A, we already said this is G, or we say that this G is E. So if you substitute the guys, you can say T is equals to M into bracket A minus A, or M into bracket G minus G. So M, A minus A is 0, or M, G minus G is 0. So whatever the case is, the tension on the rope is going to be 0. There will be no tension on the rope. Don't forget what you're interested in is the tension on the rope, the force on the rope that's taking it up and down. Do you understand? Any question on this, please? We now move to Then the back cost question. Now, when we suspend an object in a lift, let's say instead of this man staying inside this lift, we suspend an object without using a spring balance. So what is going to be the condition of this suspended objects? It is not different from everything that we have described here. It is the same formula, the same value. You understand? If it is going up, it's the same thing. If it is coming down, it's the same thing. If it is if it is free fall, it's the same thing. You understand? So it's not a different case. The formula, I believe that is clear. The question says, an elevator of mass, I'll just read the question. An elevator of mass 4,800 kilograms supported by a cable. So the mass of the elevator is 4,800 kilograms. Supported by a cable which can safely withstand a maximum tension of, so the tension the cable can withstand is 60,000 Newton. Let me take the question again. An elevator of mass 4,800 kilograms is supported by a cable which can safely withstand a maximum tension of 60,000 Newton. The maximum upward acceleration A the elevator can have is, so what can be the highest acceleration? Upward acceleration, don't forget, going up. Take G to be equal to 10 meters per second square. Very simple. It is going up, so we are going to use upward formula. So we say T is equals to M into bracket G plus A. T is 60,000. M is 4,800. We are looking for A. So we just say 60,000 is equals to 4,800, 10 plus A. Divided by 4,800. Divided by 4,800. So 600 by 48. 600 divided by 48. That gives you 12.5. So 12.5 is equals to 10 plus A. Take 10 here. 12.5 minus 10 is equals to A. And A is equals to 2.5 meters per second. And that is option A. We have 2.5, 5.0, 7.5, 10 meters per second square. Any question on this? Any question on this? Okay. I have another question from I'm actually supposed to read this question. Okay, this is what I would do. I import the question so that we all can. So I sent a question on the charts. So I want to import, so I don't have to read the questions. I'll just solve 1, 2, 3, 4, 5 of the questions, and we'll call it a day today. This one. So assuming the question talks about coming down now, just have to use, instead of plus, we just use minus. That's it. As simple as that. Very simple. Do you understand? But you know, theories can be a bit funny. Okay. So yeah, it says 2 balls and y. Weighing, you can see the down current 2011, very recent here. 2 balls of different masses weighing 5 kilograms and 50 5 grams and 50 kilograms respectively were thrown up vertically at the same time with the velocity of this. How will their positions be 1 second later? I have this question, but this is not what we want to do. But for the sake of the fact that we see the question, we can see the question, let's just solve it. What do you guys think? So 2 balls of different masses weighing 5 grams and 50 kilograms respectively were thrown up vertically at the same time with a velocity of 100 meters per second. So let's write the velocity. Velocity 2 is it is how will the operation be 1 second later? So the time is after, and it's thrown up. So it's upward motion. You know that, right? And at upward motion, our axis was negative, right? Don't forget. So position is distance S. We have to find S distance. That's what we're looking for. What format do we use? SUGT. So we have is S is equal to UT minus half GT squared. So it's 100 times 1 minus 1 over 2. G is always 10. 11 is given times 1 squared. 1 minus 1 is 100 minus 2 is 1. 2 is 5. 5 times 1 is 95 meters. Look at the one that can you hear me?
Yes, sir.
So the network just went off. Can you see my screen also?
No, sir, we can't see it. You've not shared it.
Okay. We have 95 minutes here. I have a solution is speaking to 95. I can only see. So how would the operation be 1 second later? I don't even see it. X will be 500 meters ahead of Y. X and Y will both be 500 meters from the point of flow. X and Y will be 500 meters from each other. Y will be, if you're going to do everything in this way, because sometimes you need to read the question before you know the answer. Just so that. Now, in physics, can you hear me? You can't hear me. Can you hear me? Can you hear me?
No,
I'm
sir.
now.
No, sir.
You can't hear me at all.
It's not clear.
What I saw is not clear. Can you hear me? It's two different things.
No,
Can
we
you
can't
hear
hear
me?
you,
That's the
sir.
question. Can you hear me?
No, we can't hear you.
The audio is cracking.
Okay. Okay.
It is cracking.
Mhm. When you take the recordings, I see that it's very clear. Okay, is it better now? This one that is not
It
guessing.
is better. It is better now.
It is better now.
Yes, sir.
Thank you. Now, for this question, we are not even supposed to solve anything. We're not supposed to solve anything. The question is, this question wants to test our understanding of if mass is going to affect the rate at which something goes up or comes down. So one of the things that Newton made us to realize was that if you release an object at the same time, no matter how big or small the object is, you can see the two masses. They are different. They have different masses. So if one is 50 kilogram and the other one is 5,000 kilogram, if you throw them at the same time, they are going to hit the ground at the same time, provided that air resistance is what is negligible. That is not considered the effect of air. So this is what this question is testing. Our understanding of the fact that when you release two objects from, they are going to get down at the same time. So option A says the 500 meter ahead, I know. X and Y will both be 500 meters from the point of flow. This is the correct answer. They are going to be at the same time. X and Y will be 500 meters from the point of flow. Y will be 500 meters ahead of flow. The correct result.
Oh, your
It's
voice is
cracking.
cracking.
It is
Sir,
cracking, sir.
That
your
one
voice
does
is
not
cracking.
require that you solve anything. It's correct.
All right, sir.
This
The voice is
correct.
cracking.
It's cracking.
Check and still cracking.
Is it still cracking now?
Yes, sir.
Yes, sir.
Yes, sir.
You can everybody say no, sir. Can everyone say yes, sir? Is it still cracking? Is it better? Or is it still cracking?
Yes, sir.
It's still crackling.
Oh, it's from your network, then it's not from my own network. Is it better?
It's not better.
Aisha, it's better. Yeah, that's why it's better. Okay, is it better now?
It is still cracking.
It is still cracking. Yeah. Still cracking. Still cracking.
Yes, sir. It is still cracking.
Is it better now? Is it better now?
Yes, sir. We can hear you
Yes,
clearly.
sir, we can hear you.
Good. So we understand question 22, right? I'm not sure. Is it still cracking?
It started
I see
again.
some sound.
Yes,
Started
it has started again.
Ah. So I think it's actually this part. Is it better now?
Yes, sir. It is better now.
Good. Now this one's when this is the man stands on a spring, scale placed in a lift. The lift descends at constant velocity. As a result, the scale reads a weight A greater than the weight of the man, B same as the weight of the man, C 0, D less than the weight of the man. What's the answer? I didn't explain something that would make you understand this one. Although, with everything we've done under motion, you'll be able to answer this question. But let me explain something. Remember that when we say we have constant velocity, what do we mean? It means that our acceleration is 0. Do you remember? Good. Now, put that in the formula of, is it going up or coming down? Descent coming down. So T is equals to M into bracket G minus A. So E is already 0 from the word constant velocity. So T is equals to what? M into G minus 0. So T is equals to what? Mg. So as a result, the scale is going to read a weight that is what? The same as the weight of the man. Because this mg is the weight of the man. You get it? Is that clear? So it's going to read as the same as the weight of the man. Don't forget the turning point here. What gave us the answer is this constant velocity. Everything must sink in your body. Once you see it like this, even you will know that this is the answer. Question 24. A 1,000 kilogram elevator is descending vertically with an acceleration of this is coming down. Acceleration of this. If the acceleration due to gravity is this, the tension in the suspension cable is what? This same formula again. C is equals to M is 1. Our G is 10 minus A, which is what? A is also 1. Okay, our M is 1,000. Sorry. Our T is going to be equals to 1,000. 10 minus 1, 9. Our T is going to be equals to 9,000 Newton. Do you get it? Option C. Question 25. A man standing on a lift that is descending does not feel any weight because a man standing on a lift that is descending does not feel any weight because there is no reaction from the floor to the lift. There is no gravitational pull on the man in the lift. The inside of the lift is airtight. The lift is in vacuum. Now, tell me to answer that question. The answer to this question is going to require that I explain some things. Question 26. Which of the following is not a force? Which one is a force? Tension is a force. Upthrust is a force. Impulse is not a force. So the correct answer is what? G. Impulse is not a force. Friction is a force that opposes motion. Tension is the force on a spring. Upthrust. What kind of force is upthrust?
In a liquid.
Who said that? Who? I can't say the thumbs up. I can't listen.
Like me, Atia.
Tia, how are you?
Fine, sir.
That's correct. It is the force in a liquid. We call it buoyant force. And here, the correct answer to 25 is A. There's no reaction from the floor of the lift. That is why that's the object, but the man standing on the lift is not going to feel any weight. So in the next class, I'm going to explain the concept of this. So I think we have done justice to a bit of things that are important here. Like I told you guys, in our next class, we are going to be expanding more on some concepts. We are moving gradually, and I love the way we are going in physics. Now, the bottom line now is that in our next class, it's going to be continuation. But on Sunday, we are going to have testing. On Sunday, there's going to be test. There's going to be a full-fledged test. 40 questions, all the subjects. And 50 questions English. Full-fledged. Full confirmed jam question. Confirmed jam on everything we talk to class one. Normal standard jam time. So we are it's going to make us separate the men from the boys. We're going to know who exactly is going to move. You know that class that I've been telling you guys about? That dedicated class. This is the time for us to switch people, to move people. We are going to move people based on we're going to move people based on their performance. Based on their performance, not based on if you know the lead tutor or you know the class progress monitor, or you know anybody you know. We're going to move you based on